Hello. So today we are going to talk about the addition rule. And this is a short section. It actually complements the multiplication rule. So let's get to it. So for the addition rule, we have two objectives. The first is to figure out how to determine whether two events are mutually exclusive. And the second is to figure out how to use the addition rule to find the probability of two events occurring. Okay, so I would like to point out here that when we say mutually exclusive, keep in mind that that is essentially in contrast with independent. So we had independent versus dependent, and now we are looking at variables being mutually exclusive or not mutually exclusive. Okay. And we used independent versus dependent in our formulation of the multiplication rule. Okay. And we're going to use mutually exclusive in our formulation for the addition rule. Okay. So here's the definition of mutually exclusive. Two events A and B cannot occur at the same time. Easy example. Suppose so our probability experiment is rolling a die. Event A is going to be rolling an even number, which would be 2, 4, 6. Event B is rolling an odd number, 1, 3, 5. There's no way that you can roll an even number and roll an odd number. So in this picture here, we would have 1 or 2, 4, 6 over here, 1, 3, 5. And you can see how these events are mutually exclusive. Now, if we were to instead have a different setup for A and B. So suppose A is roll, event A is to event A equals roll an even number, so 2, 4, 6, and event B is to roll a number that is at least 3, so that means 3, 4, 5, or 6, then events A and B are not mutually exclusive because in the overlap you've got 4 and 6. So if you can see right here what we've done, I don't know if you can see this part right here, but we've got 4 and 6 in the overlap. Okay, so for our picture, we would have like 2 over here, and then we'd have 4 and 6 in the overlap. And then for event B, so do you see how event A is 2, 4, and 6? And now event B, which is over here, is going to be 3, 4, 5, and 6. So A and B are not mutually exclusive. Okay, so let's practice determining if events are mutually exclusive. Event A is to roll a 3 on a die, and event B is to roll a 4 on a die. And we can actually write this using set notation. So we say this is equal to just 3, and event B is equal to just 4. So since there's no intersection, there's no overlap, these are going to be mutually exclusive. Okay, so since the events can't both occur at the same time, since none of the outcomes in the events can occur simultaneously, we say that the events are mutually exclusive. Now let's look at another example. What if event A is randomly selecting a male student and B is randomly selecting a nursing major? These are not mutually exclusive because so if we were to draw a Venn diagram, A, is selecting a male student. So these are male students. And B is selecting nursing majors. Okay, nursing majors. You have some male nursing majors, right? So there is an overlap. You can be a nursing major and also be a male student. So we are not mutually exclusive. Let's go to the next slide here, which is actually going to give us our formulation for the addition rule. Okay, so the addition rule, the probability that events A or B will occur, this is our general formula, is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, if A and B are mutually exclusive, so if A and B are mutually exclusive, then we've got this simplified version. So we've got the probability of A or B is equal to the probability of A plus the probability of B. Because notice that if, so let me write this down. So note, if A and B are mutually exclusive, then the probability of A and B occurring is equal to 0, right? Because what does it mean to be mutually exclusive? It means just that. The probability of both events occurring is equal to 0. And just like our other rules, the multiplication, the addition rule can be generalized to any number of mutually exclusive events. So just to recap, what do we have so far in terms of our rules? So this is to recap. So to recap, we have our fundamental counting principle, which said that the number of times that two outcomes can occur is going to be m times n, where m is the number of different ways that the first event can occur, and n is the number of ways that the second event can occur. Then the number of ways that both events can occur is just m times n. We have our multiplication rule, and we have our addition rule. Okay, and so these three rules are going to be the foundation for us computing probabilities. The one that we are actually going to use the most perhaps is the multiplication rule, because it is involving, the multiplication rule involves the probabilities of the P of B given A, conditional probabilities, right? So this is involved in the definition. When you're calculating multiplication rule, you're trying to calculate probability of A and B, right? So probability of A and B. When you're doing addition rule, you're trying to calculate the probability of A or B. And the fundamental counting principle is really just telling you how to compute the denominator in each of these fractions. Okay.
It's 22:30.
All right, thank you. So let's do an example here. You select a card from a standard deck of cards. Find the probability that the card is a 4 or an ace.
It's 10:30.
So here's what we want to do. So we want to find the probability that it is 4 or an ace. Okay, so we're in a situation where we are trying to compute the probability of A or B. Now we've got two formulas, and our question is, should we use the first formula here, formula number 1, or if we can actually use formula number 2. Formula number 2 is going to come into play when we have mutually exclusive events. So let's check if 4 and ace are mutually exclusive. So if event A is choosing a 4, and event B is choosing an ace, then A and B are mutually exclusive. So the probability of A and B is going to be equal to 0. A and B are mutually exclusive. So what this means for us is we can use the formula that the probability of 4 or ace is equal to probability of 4 plus the probability of ace. Probability of 4 plus the probability of picking the ace. So now what's the probability of 4? This is going to be, how many different 4s are there in a standard deck? Well, there are 4, so this probability is going to be 4 out of 52. And how many aces are there? There are 4, so this is going to be 4 out of 52. So we're going to get 8 out of 52, which is equal to 0.154. Okay. Let's do another example. You roll a die, find the probability of rolling a number less than 3 or rolling an odd number. So let's see here. So we want the probability of rolling a number less than 3 or an odd number. Okay, so A is going to be our event of rolling a number less than 3, which means we need to have 1 or 2. And B is going to be rolling an odd number, which means we can get 1, 3, or 5. Are A and B mutually exclusive? No. A and B are not mutually exclusive because look, you can 1, if you roll a 1, that means you're in A and you're in B, right? So when we have our formula, we can't use our simple formula. So our formula is that we're going to use is going to be probability of A or B equals probability of A. So let's go back and look. We have to use this formula right here because our events aren't mutually exclusive. So we'll have probability of A plus probability of B minus the probability of A and B plus probability of B. I can do a better job. Okay, so we'll have probability of A plus probability of B minus the probability of A and B. Okay. Now, what is the probability of A? So let's do this in a different color. Probability of A, what is that? Well, that is the probability that you get a 1 or a 2. Okay, so the probability of A is going to be 2 out of 6. What's the probability that you get B? B is to get an odd number. Well, that's going to be 3 out of 6, which is the same thing as 1 out of 2. Okay, and now what is the probability that you get A and B? So in order to get A and B, we can write over here that A and B is going to be, what is it going to be? It's just going to be the set 1. Because what does it mean to be in A and B? That means that you're less than 3 and you're an odd number. So that means that you're equal to 1. So the probability of getting A and B is going to be 1 out of 6 because there's only one way, which is if you roll a 1. So we need 2 6 plus 3 6 minus 1 6. Okay, so our probability is going to be equal to 4 over 6, right? So that's 5 minus 1, 4 over 6. And this is about 0.6667. Just say 66.67%. Okay. All right. So let's move to a different example. And so now I would like for you to please read this example. Excuse me. So take a moment, read the setup for this problem. This is going to be a type of empirical. So this is We're calculating an empirical probability. Okay, so how are we going to do our question? How are we going to solve our answer here? Okay, it looks like what we're being asked to find out is what is the probability that the sales representative will sell between 75,000 and 124,999. So we're talking about 75,000 to 124,999. So what we want the probability that you're in this range, 75,000 to 99,999, or you're in the range of 100,000 to 124,999. Okay, so this tells us what we should let our A. So we want the probability of A or B. And here A is going to be the event that you have monthly sales between 75,000 and 99,999. Okay. And B is going to be the event that you have monthly sales between 100,000 and 124,999. And these are, of course, the units are dollars. So, going back to our formula here, we use the addition rule. And now let's go back to see what does the addition rule say. So here's what the addition rule says. It says that the probability that events A or B will occur is probability of A plus probability of B minus the probability of A and B. And if we know that our events are mutually exclusive, then this simplifies to probability of A plus probability of B. So now what is the probability? Are and B mutually exclusive? The probability that is what's the probability of getting A or B? And we know that with the addition rule, the first
It's
thing
22:45.
Thank you. The first thing we need to consider is if our events are mutually exclusive. Looking here, it is possible for someone to have type B and be Rh negative.
It's 10:45.
So, since the two events do overlap, we conclude that the events are not mutually exclusive. And so, since the events are not mutually exclusive, we will need to use this formula. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so let's rewrite that here. So we're going to have probability of A or B equals probability of A plus probability of B minus the probability of A and B. Okay, so now what is the probability of event A? Event A is the donor has type B. So donor has type B. So what's the probability that the donor has type B? Well, that's going to be 45 over 409. And I think maybe we used that. No, we didn't. Okay. But similar reasoning. So we'll have 45 over 409. What about the probability of event B? Event B is that the donor is Rh negative. So what's the probability that the donor is Rh negative? So let's see. Rh negative, there are 65 Rh negative people out of the total sample of 409. So we'll have 65 over 409. Okay, and now what's the probability of A and B? Ooh. So our event A and B is the donor has type B and the donor is Rh negative. So how many people have type B and are Rh negative, to have type B and your Rh negative, there are going to be 8 people in that situation. Okay, so the probability of A and B is going to be 8 over 409. Okay, so now add and subtract. So that's going to be 110 minus 8, which is 102 over 409. And that is approximately 0.249, which is about 24.9%. Okay. All right, so that sums it up for our summary here. What do? We learned how to determine if two events are mutually exclusive. That essentially means that means that the probability of A and B is equal to 0. Okay, and this plays a role in which addition rule formula you use. So we've got two formulas. The first one is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, right? And so if probability of A and B equals 0, which is the same thing as saying if A and B are mutually exclusive, then the probability of A or B is just going to be probability of A plus probability of B. All right, there you go.